Good afternoon everyone, I am Mr. Rich. Thank you for joining me for this video. In this video we're talking about a very important point with regards to differential equations. What you see here before you, y equals ax e to the x, is not a differential equation because you don't see a derivative factor in it. It, however, is a function which can be converted into a differential equation. That differential equation can then be solved. The most important point of this particular video is when a student is provided a differential equation and they are asked to solve that differential equation, two different students can arrive at two different answers. Those answers may be the same, but their presentation or their appearance is quite different, and that is a peculiarity that you should be aware of. But before we get into that main topic, let's look at this function and convert this. Let's form a differential equation from what we see here. First task is to determine how many constants they are. I see 1. Therefore, I'm going to do one derivative step. Do one derivative step of this entire function that you see right here, and then go from right over there. When I'm doing the derivative of y, I'm getting a dy over dx. I have a which can be pushed out, then I'm doing a derivative of this x e to the x, which is a product of two functions for which you do the product rule. If you do the product rule properly, you'll have e to the x plus x e to the x. The f function, the g function through the product rule template. That's exactly what you'll have. Solve for this a. Remember, what I'm doing here is converting this function into a differential equation. That differential equation will then take us through the main topic or the main theme of this particular video. E to the x plus x e to the x. Now this is what I've determined for a. Come back to this equation right here and substitute all of this in the place of a. I have y is equal to all of this, but I'm going to do abbreviation. I have y prime. dy over dx is y prime over e to the x plus x e to the x. I'm going to isolate e to the x. I'll have 1 plus x times this. I have x e to the x. Now see what I've done. I've substituted the substituent for a right here in the original equation. I can cancel this out with that. I end up seeing y is equal to y prime x over 1 plus x. I can take this on the other side. I have y times 1 plus x is equal to, now I'm going to bring in the proper terminology, dy over dx, x. I'm going to take everything onto one side and equal this to 0. I'm going to do that. I'll have x dy over dx minus y parentheses 1 plus x is equal to 0. This right here represents a differential equation which has been formed or developed from this function right here. Now back to the main topic of this video, the main theme. If I gave this question to two students, there's a good chance that the two students will solve it out correctly, but they will arrive at two different answers, and let's see and explore why that is the case. And you should be familiar with that. You could solve a differential equation and over two instances arrive at two different answers. They're still the same, but in appearance they're different, and you should be aware of that. When you're looking at the differential equation, what's the first thing you want to do? Let's start with x dy over dx. Take everything onto the other side. I have a 0, but then that y parentheses 1 plus x ends up on the other side. Take the x on the other side. Dy over dx is equal to y parentheses 1 plus x over x. Now you know the varieties of means there are for solving a differential equation, one of which is separation of variables, and that's what you want to do here. Take the y on this side, you'll have 1 over y, dy over dx is equal to 1 plus x over x. The variables are separated. Now integrate them, and that will be the technique you would have utilized here. When I'm doing this, I'm getting a natural log of y. When I'm doing this, I'm separating this into their separate integrals. I can do 1 over x dx plus x over x dx. Combine these two and you'll end up with exactly that. But when you do this in terms of its antiderivative, you have natural log x plus, this is just an integral of dx, which is just an x, but don't forget this c. Now this is a point where we've arrived at, which most students will arrive at, and this will branch out into two different answers, one of which will be this. Because remember, if we started with this function and developed that, to solve it out, you should end up here. That's fine, but you can also end up at another answer based on how you carry out your procedures, and let's look at that. When I'm looking at this, one procedure one student will do is this. They'll do natural log a is equal to c. They'll bring that substitution in here. They'll have natural log y is equal to natural log x plus natural log a. They'll combine the common terms, which are these natural logs. I'll have natural log y is equal to natural log ax. Remember, sum of individual logs is equal to their product under a common log plus x. Now take the y and solve for it. Take natural log on the other side, you'll have e exponent natural log ax plus x, which, if you are cognizant, you can use the properties of logs and the properties of exponents to separate them out. You're really looking at here y is equal to e ln ax times e to the x. Think about it, common bases, exponents add, and you get this. When you look at this using properties of logs, you know you're from here just getting ax, and then you're getting e to the x, and this right here is exactly what we started out with. So one student will arrive at that. Remember a very important fact, this is equal to ax. Why is it equal to ax? Think about your properties of logs. I can very quickly show you here on the bottom, and you can see it. Y is equal to e to the power of ln ax. Bring the properties of logs into the picture. Ln y is equal to ln ax ln e, which is equal to 1. Bring this onto the other side, it would divide under a common log. It would be really a difference. You can say ln y minus ln ax is equal to 0. Then you have ln y over ax. The difference of two separate logs is equal to their quotient under a common log. Y over ax is equal to 0. Take the natural log on the other side, you'll have y over ax is equal to e to the power of 0, which is equal to 1, and then y is equal to ax. Hence, this right here gave me this ax you see right over here. Anyhow, jumping back, I'm confident you knew about this property of log over here. You know anytime you see something like this, e exponent natural log, that factor right there, that factor is equal to just that factor alone without the e and the natural log in play. Anyhow, let's come up now at the other course. I'm going to erase this because you've seen this. Everything stemming here from this branch point here. I've shown you how you could have arrived at this. I'll show you how you can arrive at a different answer. And that different answer I'll show you right over here. Starting from this branch point, don't make a substitution. There's some students which will not bring in the a substitution, the natural log a for c, and they'll carry everything from right here. They'll have natural log y is equal to natural log x plus c. They'll solve for that y, and they'll take the natural log on the other side and create the exponential base. You'll have natural log x plus c. This right here is all an exponent of this. Then what they will do is do everything here in terms of properties of exponents. You'll have e natural log x times e to the x times e to the c. Common bases, exponents add, and that's exactly what you have. This, again, by means of the properties of logs I was telling you about not too long ago, you can solve this out, and from this expression right here, you'll just get an x. Then you can combine these again under a common exponential base. You'll have e x plus c. You can write this again in a more condensed form. Y is equal to x e to the x plus c. Another student will come at this answer. So let me fix these arrows over here. From this branch point, one student will come right over here, and the other student or another set of students will come to this. Now they're both equivalent answers, but they look very different. You have ax e to the x. You don't see a constant integration c because it got resubstituted for a, and here you have x e to the power of x plus c, but they're both proper legitimate answers. This right here is the most important peculiarity you need to keep in mind when solving differential equations. There is not always 100% of the time a standard answer you can arrive at. You can arrive at a multiple different bunch of answers based on how you carry out your solving procedures or your simplification procedures, and here is an example which shows you clearly that. And that right there was the main point of this video. From this differential equation, we have arrived at two separate answers which mean the same thing, but they look very different. Keep that in mind. Thank you for watching. Have a good day.